In this lesson, we will explore the fundamental trigonometric ratios of acute angles and their applications. So let's begin by recalling what is an acute angle. Well, an acute angle is an angle less than 90 degrees. What is trigonometry? Trigonometry is a branch of mathematics that studies the relationship between side lengths and angles of triangles. We can label sides of a right triangle according to which acute angle we're interested at, because we know looking to the left, we have a right angle triangle. The square indicates that we have a 90-degree angle in that triangle. Now, all the sides can be labeled according to either of the two acute angles, so less than 90 degrees. All the angles in a triangle have to equal to 180. So if one is 90, the other together have to have a sum of 90. So both have to be less than 90 degrees. Now you label according to one of the two acute angles. And again, it would be separate labeling depending on which acute angle you choose. So in the diagram we have here, in that triangle, we've chosen to label according to this acute angle. So unknown angles are often labeled with Greek letters such as theta, alpha, or beta. We can determine any missing angle or side by using the primary trigonometric ratio. So let's just remind ourselves how we would label. So we do have the 90-degree angle. We know this is 90 degrees. I drew a little arrow indicating, as you can tell, it kind of looks like an arrow. The hypotenuse is always directly across from the 90-degree angle. Then we label, so that would go there. Then we choose, again, there's two acute angles. We've chosen this one. Opposite would be such, and then adjacent would be beside, so it'd be that side. So it's very, very critical to label your right angle triangle properly so that we can state the proper ratios according to those sides. So the sine ratio is opposite over hypotenuse. You're taking the ratio of the opposite side over the hypotenuse. In abbreviation, it's sine theta, so it's always the ratio, then the angle is equal to the two sides that they compare, opposite of hypotenuse. The cosine ratio is the adjacent side over the hypotenuse. So cosine theta, so it's always the ratio followed by the angle, that acute angle measure, is equal to adjacent over hypotenuse. And then the last one was the tangent ratio of the primary trigonometric ratios, and that is opposite over adjacent. So tan theta is equal to opposite side over the adjacent side. A quick way to remember the trigonometric ratios would be the acronym SOHCAHTOA. And this is something that stuck with me when I was in high school. It just gives us an easier way to remember which two sides each ratio is comparing. So sine, SOH, OH, opposite of hypotenuse. Ka, cosine, adjacent over hypotenuse, A over H. And tan, TOA, opposite over adjacent. So in example 1, we're given triangle ABC. We're going to solve the triangle. Now again, we don't start solving anything until we label everything properly. So there's my 90 degree. So we know this is going to be my hypotenuse. Now the acute angle of 51 is given, so we're going to be labeling everything according to that angle. So again, the opposite side would be side AC, and this AB would be the adjacent side. Right? So we'd start with, if we're solving the triangle, that means we need to determine all the three sides, all three angles. Now, we can probably start right away by figuring out angle C, because we know all the angles together have to equal to 180. So if we take 180 minus 90 minus 51, that would give us the measure of angle C. So 180 minus 90, which is 90, 90 minus 51, which would be 39 degrees. So we got one measure completed of that triangle. We still need to know the length AB, that side, and the side length AC. So with that, because we are given the opposite side, right? Sorry, the hypotenuse, and we need the opposite side. So we'd say sine, OH is sine. So sine of 51 degrees is equal to the opposite side, which is AC, over the hypotenuse, which is 12. So again, notice I circled the hypotenuse, that's given. I started to figure out side AC, which is the opposite. OH, the only ratio that has OH, which is comparing those two sides, is sine. So we write the sine ratio, then we put the angle, which is equal to the ratio of the two sides. So AC over opposite side, AC over hypotenuse, which is 12. Now, cross multiplying, again, that's like an imaginary 1 there. Cross multiplying, AC is going to be 12 times sine of 51 degrees. Keeping in mind, it's very critical that your calculator is set to degree mode because there are different modes of angles that your calculator can use for units. We want to make sure your calculator is in degree mode. So 12 sine of 51, rounding, say, to the nearest tenth, would be about 9.3 centimeters. Okay, this time we have the hypotenuse. We need the adjacent side, so the last side to determine, looking at SOHCAHTOA, which ratio compares the adjacent side over the hypotenuse? CAH, C-A-H. So that means we'd write cosine, then the angle, because we labeled everything according to that acute angle, is equal to the adjacent side, which is AB, over the hypotenuse, which is 12. Again, cross multiplying, 1 times AB is AB. It's equal to 12 cos 51 degrees. And again, rounding to the nearest tenth, AB would be equal to about 7.6 centimeters. Okay, we also have reciprocal trigonometric ratios. Now, the cosecant ratio is the reciprocal of sine ratio. So sine we know is opposite of hypotenuse. So the reciprocal, which means we would just flip it, would be the cosecant ratio, which is the hypotenuse over the opposite side. That's why we indicate the reciprocal formula would be cosecant ratio theta is equal to 1 over the sine ratio, so 1 over sine theta. The secant ratio is a reciprocal of cosine. So we know cosine, is comparing adjacent side of our hypotenuse. Therefore, secant would be its reciprocal, hypotenuse compared to the adjacent. So again, secant theta is 1 over cos theta. And the cotangent ratio is the reciprocal of the tan ratio. Tan we know is opposite over adjacent. Therefore, cotangent would be adjacent over opposite. Moving on, we have determine the 6 trigonometric ratios for the given angle in triangle XYZ. So with that in mind, again, we always start by labeling. So the 90-degree angle is here. So across from that would be my hypotenuse. Notice they've indicated the angle measure, which is angle Z, with the symbol theta. So opposite theta would be side XY, and that would be my adjacent. So if we're determining the 6 trigonometric ratios, it's always best to start with the primary ones and then determine the reciprocals. So we know sine theta is equal to opposite, which is 3, over hypotenuse, which is 5. So therefore, the cosecant ratio would be its reciprocal, which would be 5 over 3. The primary trigonometric ratio cosine is the adjacent side, which is 4 over the hypotenuse, which is 5. Therefore, the secant ratio is its reciprocal. Secant theta is 5 over 4. And the last trigonometric ratio is tan theta, TOA, opposite over adjacent. So it's opposite, which is 3, over the adjacent, which is 4. Therefore, the cotangent ratio, which is tangent's reciprocal, would be 4 over 3. Most calculations do not have buttons for cosecant, secant, and cotangent theta. So if you look at your calculators, you won't see those. You'll see sine, cos, and tan. However, to calculate it, you would take what that would be for the primary trigonometric ratio and then take its reciprocal. So let's evaluate the following to the nearest hundredth. So making sure again that the calculator is in degree mode, we would just input cos 43 degrees. So to the nearest hundredth with 2 numbers after the decimal. So that would be 0.73. Notice I put an equal to dot on top to indicate that it is rounded. Sine is 75. Again, that is the primary trigonometric ratio. You're going to find that button on your calculator. Secant, you're not going to find. So what we need to do, we know that secant ratio is the reciprocal of cosine. So that would be the same as 1 over cos of 27 degrees. That you can calculate, which is about 1.12. Cotangent ratio, again, that is the reciprocal of tan. So 1 over tan at 83 degrees, we can calculate. So that would be about 0.12. Cosecant, again, is the reciprocal of sine. So 1 over sine of 59 would equal to about 1.17. Okay, example 4. We're going to determine the value of the given angle to the nearest degree. So when we're determining angles, again, if you're separating the ratio from the angle, so that means sine has to come to the other side of the equation. And by doing that, we need to determine the inverse. So keeping in mind, theta is going to equal to the inverse of sine at 0.7235. Keeping in mind in your calculator, just shift sine. So theta is going to equal to the nearest degree, about 46 degrees. Now again, as we mentioned earlier, the primary trigonometric ratios, those buttons do exist on your calculator, but the reciprocals do not. So what we would do is indicate cosecant beta, which would be the reciprocal of sine beta. Okay, so if we take the reciprocal of both sides, this would become sine beta is equal to 1 over 1.2711. So you just take the reciprocal of both sides. Now we can isolate for beta, the angle measure, because that's what we want. Keeping in mind when you take the ratio from one side to the other, you do have to do its inverse. Okay, now the question is in terms of the primary trigonometric ratio, which we can use our calculators to calculate. So taking the inverse of sine at 1 over 1.2711, that means beta is equal to about 52 degrees. Secant, the reciprocal of secant is cos theta. Cos theta would be the primary trigonometric ratio, and secant would be its reciprocal. Is equal to 1.4506. Again, we would take the reciprocal, so cosine theta is equal to 1 over 1.4506. We need to get the angle by itself, so we have to get rid of the cos. So bringing that over, theta is going to equal to the inverse of cos. So therefore, theta is equal to about 0.81 degrees. Applying what we learned above, we have example 5. A wire supporting a telephone pole is secured to the ground at a point 16.7 meters from the base of the pole. So there's our pole, 16.7 meters. Keeping in mind the pole should be perpendicular with the ground. That means we have a right angle triangle. We can use our trigonometric ratios. The wire makes an angle of 48 degrees with the ground. So there's our angle, the wire connecting with the ground. Find the length of the pole. So our unknown is the length of the pole. So we're going to let x represent any unknown. We have to have a let statement. Let x represent the length of the pole. Okay, and then we have to properly label the right angle triangle. So again, we know the 90-degree points to the hypotenuse. We always label that first. Across from the given angle would be the pole, and the ground would be the adjacent. From there, we have to decide which ratio to use. We are given the adjacent side, okay, require the opposite side. So we would write out SOHCAHTOA to remind ourselves our options. And now, which ratio compares the opposite side to the adjacent side? So the opposite of adjacent would be tan, because that's the only ratio that compares those two sides. So stating our trig ratios, we know tan followed by the angle, which is 48 degrees, is equal to the opposite side, which is x, over the adjacent side, which is 16.7. Cross multiplying, 1 times x is equal to 16.7 times 10, 48 degrees. Putting that into our calculators, x is going to equal to 20.04, but we're rounding to the nearest meter, so that is rounded to 20 meters. So therefore, the length of the pole is about 20 meters.